Today we're going to take you through the entire process now. We've kind of gone through each step, and then we're going to put it all together. All right? So our big question is, what is the missing force? So we're trying to figure that out right there, that question mark. We got to develop as a process, and here's kind of the way I handle things. The first question we always want to answer, is it statically determinate? To put it another way, is this even possible to solve? So to do that, we usually take a look at this formula. The formula is right here. 2J equals M plus R. J equals the joints. So let's circle those. So right here I've got one joint, 2, 3, and over here 4. A joint is basically where all the members meet up, right? So on the left side of this equation, I have an 8. So now I'm going to look at members. And members are the bars themselves. So there's 1, 2, 3, 4, and 5. I have a 5 there. Plus, then the reaction forces. Well, this is a pin, right? So a pin, if we remember correctly, equals 2. And then a roller over here equals 1. There is a total of 3. So the question then becomes, the left side is 8, the right side is 8. Those two are equal. So yes, this one is statically determinate. So check. Now we're going to go to the next step, and really it's the first step. Most of the problems you'll get in class are statically determinate. So we'll go now to determine the missing angles. And in order to get there, we've got to have some sort of angle, right? So right in here, what is this? Okay. Now we can use SOHCAHTOA for this, right? Now we know we're trying to find an angle though, so we're going to actually use that inverse thing, right? We know that this is 8, and then this length is 18. So I know the opposite, and this is the adjacent, and this is hypotenuse. Opposite and adjacent, that looks like I want to be using the tangent. So let's do that. So we're going to say tangent of -1 equals opposite over adjacent. There's our formula. So we're going to plug them in now. So we'll say tangent of -1 equals opposite, which is 8, over 18, because that's our adjacent, right? When we plug that into our calculators, I'm going to end up with 23.962 for that angle. So now I know that angle. Let's put it in there, 23.962. So let's take a look at our next step. We've now determined our missing angles. We got our determinacy. Now we're here. Calculate the reaction forces. We're going to go ahead and kind of update here. So we know that this is 23.96. We've already got that taken care of. Now we're trying to determine these, our reaction forces. So this is RAX and RAY. Because this is point A, let's make this B, let's make this C, and let's make this one D. So this would be a reaction force of RCY. We only have the one because it's a roller, right? We don't have any horizontal opposing forces, so I already know that's X, or excuse me, that's 0. But the Y's, that's what we're going to have to deal with. So the sum of all forces in the Y direction has to equal 0. Let's go ahead and set it up. So remember that moment equals distance times force, or the other way around. So we'll say 8 times 750, but this is in the negative direction, right? It's pulling us down. So we'll say negative 750 plus, we got 8 plus 18, so that's 26 RCY equals 0. So we can do some of this, right? We can say 8 times 750. It's going to give us a negative 6,000 here. We'll go ahead and combine these terms. And now I know that this has to go over here. So we'll say 26 RCY equals 6,000. And then I got to divide by 26. And when I do that, let's see here. So 6,000 divided by 26 is going to give me an RCY of 230. While I'm here, I can go ahead and figure out RAY, right? RAY. We've got 750 pulling us down. That means that we have 750 right here. So I already know that one. I've got to have a reaction force too. So the reaction forces have to add up to the same. So basically what I'm saying is 750 minus 230, right? That's going to give us what? 520. So our RAY is 520. And if we look at that, the 520 and the 230, they add up to 750. We're going to move to step 3 now. We're going to start with the fewest joints that we're going to solve. So let's go ahead and update some stuff here. Our goal here is still right here. That's what we're trying to solve here. All right, let's take a look at it. If we know we've got 230 pushing us up, we've got to have a force of negative 230 pushing us down, right? That has to equal 0. Right? So we'll come over this way too and draw us another. Now you know a few things here, right? You know, because of that alternate interior angle thing, this angle up here is 23.96. So you got that one and that one. They're going to be the same. Essentially, we took this triangle here and we flipped it over, right? All right, so we've got our forces in there. Now we're going to switch over and get back into this SOHCAHTOA. Because we should be able to find some things now, right? Here's our angle right here. So this is going to be opposite. Here is hypotenuse again, and here is adjacent. We're trying to determine that, right? At the end of the day, this is what we're after, is that hypotenuse. So we know opposite, and we're trying to define hypotenuse. There it is. We're going to use sine. So I'm going to say sine equals opposite over hypotenuse. Let's go ahead and pull some numbers out now. So sine of 23.96 equals opposite, which is negative 230 over h. Now I'm probably going to take the longest way possible here to get through the algebra. So I got to get h by itself. So we got h sine of 23.96 equals negative 230. I'm going to divide both sides now by the sine of 23.96. And that will give me that answer that I've been looking for. H, my hypotenuse, equals 566.36. So I know right here that this side, the question mark, that goal we've had is 566.36. So we started with the fewest joints we solved. Now we are here on number 4. We're going to choose the connected vector. So down here, let's update some stuff. Now let's go ahead and move forward with things. So let's get this one solved. What's the force there? Well, I've got a lot of the work done, so I'm just going to switch over and go to SOHCAHTOA. Now I've got the angle. I've got the, remember this is hypotenuse, this is opposite, and this is adjacent. Right? So I'm trying to find adjacent. We pretty well have established that when we're going in a vertical direction, we're going to use sine. When we're horizontal, we're probably going to use cosine. But let's look. So I'm trying to determine the adjacent. I have the hypotenuse. So cosine now of 23.96 equals adjacent, which we don't know, over hypotenuse, which we do know. So now we'll just take this and get that a by itself, right? So these will cancel out. So this one, the math's a little bit easier, right? So there's mine. Let's go ahead and plug that into the calculator here. So 566 times the cosine of 23.96 is going to give us 517.227. So now I can update. And I said, well, this one equals 517.227. Now, one quick thing. Let's go back to this one. You notice before we do that, our answer here is positive. When we have positive numbers, that tells us that the member is in tension. Let's go back and take a look at that 566. We determined that. When we get there, this answer is actually negative, isn't it? So it's negative 566. Anytime it's a negative answer, that tells us that the member is in compression. In other words, it's being squeezed. We've got that. We know here that this is negative, so we'll go ahead and label these. So we'll say this member is in compression, this member is in tension. All right, let's go ahead and take a look. We can actually do this member as well. So we have negative 750 pushing or pulling down. So that means we're going to have a positive 750. So since it's positive, this member is in tension as well. We would essentially continue the process, right? We're just going to continue over and over until we get this other side taken care of now. Keys here, I think, are to continually update your free body diagram as you go along.